Hi guys, welcome back to my channel. Today we're going to be looking at using Cramer's rule to solve for systems of equations using matrices, and not the Cramer that you're thinking of. It's actually was a Swiss mathematician called Cramer who came up with his own life hack for solving systems of equations. It's particularly useful for solving 3x3 matrices. That's my preferred size for using Cramer's rule. And I really think it's a little bit of a crazy rule, and I think it will be a lot easier to get into the rule using an example. So we do have the formula here for Cramer's rule. So if we have the determinant of ax over the determinant of a, that will tell me my variable x. Now, I haven't actually defined a variable for ax yet. So what we're going to go ahead and do, we're going to write up these matrices. So from our last example where we were solving systems of equations, we know that if we have some sort of coefficient matrix times by our variable matrix, that's going to equal our solutions matrix. So we can represent that using ax is equal to b, where ax and b are all matrices. And to find x, to isolate x, we can multiply b by the multiplicative inverse of the matrix A. So when we start dealing with 3x3 systems, it starts getting a little bit trickier, a little bit more complex, and it can be a lot easier to use Cramer's rule. So let's set up each of our matrices. So our first matrix A is going to be equal to our coefficients. I've got my example down here. Next, I'm going to set up my variable matrix x. And lastly, I'm going to set up my solutions matrix. I changed my mind on the color because I want to show you what's happening with this. Now, as you can see here, we need to define the determinant of AX. So where does this extra matrix AX come from? Well, if we take our original matrix, so A is equal to all of these values here, what we're going to do is we're going to replace this first column here with our solutions column. And the reason that this is going to be AX is because we're replacing these solutions in the X column, right? When we have a Y, that's going to replace these solutions into the Y column, and then with a Z, that will replace that into the Z column. So I'll show you the matrix for AX. You can see for the AX matrix, I've replaced my solutions column into the X column, and I've kept the rest of these elements exactly the same. So this is how we find AX. Let's go ahead and let's write up a Y and a Z. Again, you can see here I've replaced the solutions into the Y column for our matrix AY, and I've replaced our Z column in our matrix for AZ with the solutions matrix. So let's go ahead now and let's use Cramer's rule to solve for each of these values x, y, and z. So for Cramer's rule, we have x is going to be equal to the determinant of ax divided by the determinant of a. So let's go ahead and calculate the determinant for each of these matrices. Alright, so I've used a process for finding the determinant of the 3x3 matrices, and it worked out that when I divided that matrix AX divided by, the determinant of AX by the determinant of A, I get 1 as my solution. So what this means is that X is going to be equal to 1. Now, I've done this by hand, but I don't know if I would actually recommend doing it by hand. So for Y, I'm going to jump over to the graphics calculator, and I'm going to show you how to do it on a Casio graphics calculator. So to find Y, that's going to be the determinant of AY divided by the determinant of our matrix A. Now, from my previous calculation, I already know the determinant of the original matrix was -3, so I don't have to calculate that again. But what I can do to do this on the calculator, if we go into Option, and then we go into Matrix/Vector, and we want to find the determinant. Okay, so that's how we get there. Really, really simple. So Option, and then into MatVect, and then into determinant. From there, we can type up our matrix. So this matrix here, AY, this is the matrix that I'm going to need to pop into my calculator now. So to get this matrix up, I went into the math function and then I went into matrix vector and I selected the 3x3 matrix and I've typed in my values. So now what we want to do is we want to find the determinant. I'm going to hit enter. Oh, I've still got mine in sys. Try that again. So the determinant of my matrix is equal to -9. -9 divided by -3 is going to be 3. Now we just need to repeat this process with our last variable z, and then we'll have our solution for our set of equations. So just as a refresh, this is the last determinant that I need to find. Jumping over to my calculator, we're going to go into the option and then matrix/vector, and we're looking for the determinant. And then what we're going to do is we're going to go into the math menu, we're going to go into the matrix vector menu, and we want another 3x3 matrix. So we're going to fill in that matrix now. And now we hit enter, or you're going to hit your execute button, and we get 6 as our result for that determinant. So let's jump back and pop that in our formula now. So now we have our solution for z. So z is going to be equal to -2. So for our first value, we have x is equal to 1, we had y was equal to 3, and we had z was equal to -2. So what I would do now, I would suggest going back and double checking using that back substitution method that we've used previously, just to check that these answers are correct. All right, so that's how we use Cramer's rule to solve systems of equations, and in particular when we're looking at more complex like 3x3 and larger systems. All right, guys, see you in the next one.